Alrighty, let's get started. So final lecture of the class and then the rest of Hermit's final projects. So lecture 12. Today is a continuation of last time. So remember in lecture 11 we started looking into web application frameworks, specifically Node.js and Express. So today we're just going to continue the lesson from last time and finish out the example. So recall from last week the learning objective is we're going to make the simple fake version of Facebook. This time using a modern web application framework rather than the old style CGI. And then, and this is an example of this modern CRUD plus AJAX web app of the sort that you want to make for your project. And it also has a REST API. You don't need to do a REST API for your project, but it's a nice way to structure your code to make it kind of cleaner. So we're going to demonstrate all of it today. So today we're going to be covering the server backend part. So recall that last time we set up a lot of the code for the front end, for the actual web, what you're going to see in the web browser, which wasn't actually anything new, right? That was from the jQuery and AJAX stuff you all learned a few weeks ago. Today we're going to focus on the back end. And then, so last time is the front end code, which we'll review a little bit, this fakebook.html. And then today we're just going to do recap and the back end, which is in the server.js file. And then we're just going to really briefly recap the whole course. And recall that exam 2 is on Thursday. So I'll have office hours tomorrow, a little bit longer than usual, to help you all review from the exam. And this exam is not cumulative, right? So this is just the parts after exam 1. This is not a final exam. It's just the lectures after exam 1. No more regular lectures. And we'll look at the course schedule for the project presentation days. So with that, I'm going to switch over to the schedule. So recall that today we're at lecture 12, and then Thursday is exam 2, and that covers lectures 8 to 12. So it's basically all the lectures since exam 1, which is here, right? So exam 1 was here, and then starting in lecture 8, the same kind of deal, do the readings, understand the code examples, because we're definitely going to have kind of the code understanding things in lecture. So 8, 9, 10, 11, and 12. And then the code examples from last time and this time are already up here. And then the final project period, mostly you're just going to be meeting with your TAs every few weeks for the milestone updates. We will return the exams in class next Thursday, I believe, November 5th. But then after November, really, there's no lectures. I'll have office hours still, and the TAs you can meet with to get help in your project. And then the only 2 real class days left beyond, besides if you want to see your exam in class, you can also stop on my office hours to see exams. The same idea. I just don't want 80 people in my office at once. December 1st and 3rd are the presentations. So we'll go over the details later about what you need to present. But it should be, a natural outgrowth of your actual project. Like I don't want you to spend, a ton of time making a special presentation just for the day. It should just be a kind of a quick demo of what your project already is. Because by this time you'll be busy actually finishing up your project. So, the presentations again are pretty lightweight. We just want everyone to see what you all are doing. Okay, so with that schedule, today again is the final lecture of a 2-part series on web application frameworks. And I just want to recap what we've actually covered last time. So recall that we had this Fakebook app. So we reload. This is running again on localhost, just like all the things are running on localhost. This time it's 3000, port 3000, because the Node.js server, we just set it to 3000 just because. And then this fakebook.html is the file that we're loading. And what this does is that it has these boxes. So if I say fill up here and I click the read button, it should go make an AJAX call to the server, look at my information in some database, and then return the data, and then print out the name, job, and a pet picture. And then let's see if you're not in the database, it will say could not find user. You can create a person, so let's create a person name, I don't know, Bobby, job, student, pet, bear, JPG. So if we try to read Bobby, it's not there. If we try to create, it'll say, okay, create a new user. So now what we can do is to read, we don't need the job. We just need the name. When I read, it says Bobby, student, whatever. And if I reload, the page, and then Bobby, click. There we go, right? And then I can update Bobby's job to, I don't know, unemployed, after student, and then cat.jpg, and then update. It says okay. So now if I, let's say, reload again, if I look up Bobby, it's unemployed cat. And then if I delete, good, successfully deleted, reload, Bobby read, and I can't find user. So this is a sort of CRUD app. You know, we have the C for create, read, update, and delete. This is a sort of app we want you to build for the project, right? That you'll need to be able to create an account, do something. I mean, your app should obviously be more than this, right? Because it doesn't actually do anything. But this should be the basis for any app that requires a login, that you have users and your user does something, right? They do whatever your project proposal says. Okay, so let's go into just reviewing the HTML for the first time. So recall that the structure of this Node.js app is, as this lecture 1112, I put everything in static files. So the static files directory has, let's remove this animal picture, so we don't need this. The static files directory has fakebook.html. It has an HTML file. It has all the pictures. It has a jQuery. And then what I do is I start up the web server using node server.js. So if I don't have the web server started, notice that I can't go to the page. So if I reload, it'll just keep trying, actually. Yeah, not available, right? Because there's no web server started. To start the server, I type node space the server, the JavaScript file name for the server. So this server.js is a JavaScript file, but it's running in the server. Yes?
So you're no longer using amps.
I'm no longer using amps. That's right. There's no amps here. This is completely different. That's right. So the amp setup was for the Apache server, which is what we use in the rest of the class. So just for these two lectures, the web application framework is called Node.js, and this is completely different than amps. Yeah. So there is no amps now. I don't think I even have it started. And that's also why I put the port to 3000 so that you can run amps and run this, because the amps is on the default port 80, and this is on 3000. So if I start the server, it will say server started, and then if I visit now localhost 3000, fakebook.html, I actually see the page. So the server started, and it's serving all the static content out of the static files subdirectory. So everything in static files I can actually just access as just static files, like it implies. And recall that we need to write some code to actually do that. And the code is this, in this giant server.js code, is this important line right here, which is app.use static underscore file. So, whoops. This static underscore files is the subdirectory name. And this command, this function call or method call tells the Node.js app to expose all the files in the static file subdirectory as just static files. I mean, they say static file, which means these are pictures, these are HTML files, or whatever, and we can just access them directly. If we don't have that line, then whatever we try to visit that URL, we don't know, the server doesn't know what to do with it, because we're basically writing a web server from scratch. So if you don't say static files are located in this directory, the web server doesn't know what to do with it. You can't assume that it knows how to do anything. Whereas for amps, like you're asking, it actually has it all pre-configured, that the static files are in whatever www amps, whatever, and then the CGI script files are in www/CGI-bin or whatever. So that the Apache server is pre-configured. So we are actually configuring the Node server to do that. And the rest of this app is, remember, you have to install some prerequisites. So this npm install express is for the web application framework, and this body parser is for the post requests. So then we start this express, we start this app. This is just a lot of just setup code that you have to do just to start a basic web app. Because again, with Node, nothing starts unless you actually set it up, right? So you have to actually set up everything. But fortunately, most of these you can just copy and paste. I mean, they're just the same for every app. And the static is the important part. And then just to reference the very bottom, so the magic that actually starts up the web app is this command on the very bottom, which is app.listen 3000, which is the port number. And then when you call this method, it will start the web server and hang there and wait and listen for users to connect to you. So if this was actually on the internet, anyone can just connect to you, and this Node actually is able to handle thousands or tens of thousands of people connecting at the same time, and it does all the magic in that handler. Yes.
So what does body parser do?
Yeah. So body parser, we'll actually get into in a second. So what body parser does is that this parses the post request bodies. So recall that the GET requests, all the data is in the URL, but remember when you do a post, you like create a form or something, and that kind of goes in the body in some weird format. This is just a library and Node that parses that out, that gives you access to that. And again, for your project, if you want to use Node, you're feel free to just adapt this code. I mean, just say we use lecture whatever server.js, and feel free to use this code. I mean, the reason why all the code from the class, both with the CGI version, and this is up there, is that you can feel free to use it for your project. Just make sure to cite it and say, oh, we built it off the class code. Okay, so far, that's what we have, and we're able to run a static file, which is really what you could have done from like lecture 1, right? I mean, it doesn't take that much just to load an HTML file or load a cat picture or anything, right? This is not super hard. So what we want to do now is actually implement the server side. So the server side is, if I type in John and I hit read, this does some AJAX call to the server, and it should do something, right? So again, our favorite picture here, we have a laptop here, we have a server. So this server is running now. The server software is called Node.js. And then this has as an extension Express. It also has the body parser, but that's not super important. So this is all there. When we click this read user profile button, it makes a request to the server to get, I don't know, John, right? With some parameter like name equals John. Like I need to get John's info. The server has to do something, has to run some code, and then it has to give me back some data in a JSON format. And that data is now rendered in the browser. The browser knows how to take the John data and do something with it. Right, so this is a standard AJAX call. So that we make an AJAX, we click the button, make the AJAX call to the server. The server does something, right? The Node.js code does something, gives us back this JSON data, and then we render it in the browser. So it's a standard Web 2.0 thing. We haven't actually talked about what the server is, which is exactly what we're going to talk about today. So what is the code on the server that is run to get that information, out? And unsurprisingly, that your code in the server will be written in JavaScript or JS, because all the Node.js code is all JavaScript. So if you choose to use Node.js, then you write your server code in JavaScript, which is not to be confused with your browser code, which is also in JavaScript. All right, but they're two different pieces of code entirely. Okay, so then the question is, what is the format of this AJAX request, right? Should we request some script? What parameter should be called? What should we call them? What is the kind of format of this? I mean, you can do this any way you like, but the way we're going to do it is using a REST API, which you learned a few lectures ago. So recall from the lecture a few weeks ago, I'm just going to erase this picture in a bit. Recall from the lecture a few weeks ago that this REST API is not going to look good over it. This REST API means that all the CRUD operations, the create, read, update, delete operations, are going to be written as kind of clean URLs. So we want to read John's data, right? Oh, I said Philip here, but we want to read data for a user. What we're going to do is, using AJAX, we're going to make a GET request to the server with the URL, whatever the URL of the server is, /user/the username, right? /Philip, which is the username here. And the English translation for this is get the Philip resource from the user's collection or directory. And what the server will return is, it will return data, the profile data, in JSON format. So this is just one way to do it. This is kind of a clean way. This is kind of what's called the REST form. You can also do it in this way, where you request some Python script and then you pass in the Philip as a parameter. But in this way, if you actually know, there's no parameters. The URL itself contains all the information you need. So if you want to get John, you would just put John here, or Sally or whatever here. And then it's up to the server to grab that URL and to parse it apart and to actually detect whose name you're getting. Okay, so with that API, as we recall, so how do we call this from the front end? This is the very end of last lecture. Is the front end code will make an AJAX call using the AJAX function, and it is here. It's a little big here. But basically what this is that it's the handler. So when you click the read button, we're going to make a giant AJAX call. This AJAX call, the type is get. The data we get back is JSON. And the URL is user/ the name that you put in. So this could be John, if we put in John, or Philip, or whatever. So it actually constructs a URL string with user/John, user/Philip, makes a request, and on success, once you receive the data back from the server, which is in JSON format, you try to parse it and see if there's a name, and if there is, we're going to say my name is, my job is, and set the image. And if there isn't, we just say error. Right? So this is the front end code that does all that. And now what we're going to do is we're going to actually look at the server code, right? Because somebody needs to implement the server. So again, from looking at the front end code, if you're the front end engineer, you don't have to care what language the server is written in. You know, if I ask you, you know, given this Ajax code, what is the server written in? The answer is you don't care. As long as the server can give you a response in JSON format, you don't care what the server is written in. So it nicely decouples the front and back end. So it happens that our server is written in JavaScript also because we're using Node.js, but we could use anything else. So let's look at the back end code now. So let's go to server.js. So the back end code, so first of all, in any real application, you probably want a database, right? You want to have, conceptually, you want a database that stores everybody's information, right? Like you want to have a column for name, a column for job, column for pet, and each row in your database is one user with some user ID or whatever, right? You want a database for a real app. But because I didn't want to get into creating a database and like showing you databases and everything, because it's a whole different lesson, I just kind of faked a database right here. So this is my fake database. This is just a this is just a JavaScript list. So my database is just a list of 3 objects. Each object is like a row in the database. So there's 3 users, Philip, Jane, and John. Now you see where all those 3 users came from. They're just in this piece of JavaScript right here. Because if I didn't have this and I made a real database, then we'd have to like import a database library and then set up a database and then configure it. Everything will be a giant pain. But so on your real app, don't do this, right? Have a real database because this will not persist, right? If like my thing basically if my server dies or I restart it, this will just get reinitialized the initial data. This is completely fake, right? You don't want to actually do this for a real app. You want to actually have a database on your hard drive storing data. This is just in memory in the JavaScript. So caution Taro, don't do this for real, but this makes for a good demo because it's much simpler. And this is just a list of 3 things, right? And each thing has a name, a job, whatever. So to add to this, to read from the database, all we do is we go through the list and we find the name that matches, and then we read out the whole object, which is the profile. To delete, we find the name and we just delete it from the list. To create a new user, we're just going to add a thing to the list. And then to update the user, we find the person with the name, and then we're just going to override one of these things, right? So these are all just straight up JavaScript functions to do this. The details aren't important, but conceptually, this is all the data that we need, and we can just write functions to manipulate them. And if you were to use a database like SQLite or MySQL, instead of manipulating these objects, you would write SQL commands to say select whatever, update whatever, delete whatever row, right? So that's from the database lesson that you can apply. And if you choose to use a different kind of database, there are libraries in Node to interface with every database, pretty much. So whatever you end up using for your project, just don't use this fake database. But whatever you end up using, there is a way to update the data and delete the data and such. Okay, so given that we have this fake database, to handle the GET requests, what we're going to do, there's a ton of comments here, you can read it for later. To handle the GET request, this is the code right here. This is it. That's all the code there is. So what this says, we're just going to parse this apart. What this says is we're going to, so app.get means it's an event handler for a GET request. So app is our Node and Express web app. So this says app.get is an event handler. And it says here this is the URL we want to match to. So this is sort of like a regular expression or just a string match. This says any URL that starts with /users /star. So star just means any character. Actually not a regular, it's just like a wildcard matching. So it says if you are trying to read this in English, if you're trying to do a GET request to any URL that is /user /anything, we're going to run this function. Does everyone see where that function comes from? It starts here. We're defining a function with no name, and then it goes all the way down to here. That make sense? So this is like a callback function like you saw in your client-side JavaScript. This says we're going to make a function, but this function doesn't run yet. Like, don't run it yet, just make it. And we only want to run it when somebody makes a GET request to /user/ any URL. So that's how you read these sorts of this sort of code. And this is actually very common in Node and just in JavaScript in general. So recall the in your front end code, your click handler is button whatever dot click. When you click a button, run function blah blah blah, and that means that that function's code only runs when you click the button. It doesn't run all the time. So same thing here. It says when you have an app, when someone makes a GET request to user/star, we're gonna run this function. So if I make a GET request to some other crazy URL, this function will not run. It will only run for user/star, and star means anything. Okay, so that means that when I make a request for /users/Philip, this function will run. If I make a request for /user/John, this request will run. And this is all a relative path, so it's assumed that the URL is localhost or whatever. It's just the directory name after the URL, after the domain. So whatever we're, and /user/ who else was there? Jane or Bob or whoever, it'll all run. And so what we need to do is in this function, we need to grab what this name is, right? Because we need to use the name to look up in the database. So conveniently, the function provides, this is it right here. So the function that's run takes two parameters, which is a request and a response object. And the way to get the name is request.params0. And this is the thing in the star. And again, this is just part of the Node, the Express package says that's how you get it. So we're just gonna get the name. So this will be Philip or John or whatever. And then all this code is that this is just a for loop to look through the database. So this would be SQL or SQL code if you had a SQL database. This just is a simple for loop, looks through the database. And here what happens is if the name in the database row matches the name you're looking for, we're going to send the whole piece of data in that row. Res.send means we're just going to send it back to the browser. And then we want to return because we don't want to send more than one. We just want to send the first match we find. Because we're assuming that there's only one person with that, there's only one row with that person's name. Every name is unique. We do a send and return. So if we do this for loop, if we're looking for Bob and Bob is not in the database, we're going to go through the for loop a bunch of times, one for each row in the database, and we're done. We can't find it. So then the end, if we're out of luck, we're just going to do a res send of an empty object. So that means that if we send an empty object, that means we haven't found it. So that's why in the client code, we have to detect whether we got an object with a name parameter or we just have an empty object. So this is kind of the error case because we want to send something, right? Because they're expecting some piece of JSON. So the simplest piece of JSON, one of the simplest pieces is just do a bracket, which is just an empty object, which represents we can't find anything. So the key part here in the code is this rec param0, which looks for the name. And just to recall in the database again, what this weird for loop is doing. All it's doing, you can study this offline, but this is just standard JavaScript. I didn't use any libraries or anything. The standard JavaScript is, all it is going through here. So this is a list, and the for loop just goes through this list and then looks for the name that matches the name you want to look up. If it finds the name, let's say you're looking for John, not a match, match. If it finds it, it'll just grab this whole element and just return it and send it to the browser in JSON format. And then the browser can do whatever they want with it. So I'm going to highlight the code again. And let's see. Get is here. So this is the get code. So just to make it a little more clear, we'll just do a console log. So the difference here between this and CGI is that you're not actually printing the result back. You're using this res or result object to explicitly send the data back to the browser. So res.send is what sends the data from the server back to the browser. So you have to call the send function. So if I actually do console.log, I will actually just print out to my terminal on the server. So let's actually do that. Let's do console.log get request for name to look up. So what this will do is if I restart the server, whenever there's a get request, I'll print out get request for the name, and then I'll actually do the thing. So I'm going to save it. I'm going to restart the server. So remember that if you modify the code and your server's still running, you have to restart the server. So this is sort of like reloading your page in the browser. So we have to close the server and then restart it. And now when I restart, notice what happens on the command line. So I'm going to make a GET request. So let's reload. So if I make a GET request here, so Philip, so make sure there's no output on the terminal yet, right? Well, besides the thing that just started. So look down here. If I make the request for Philip and I say read, oops, I just do it again. It says get request for Philip. So this actually just print out to the console and it print out that name that matched, right? So that's one way to debug. A pretty good way to debug your Node.js script is you just do a console log because it's just a program that runs on your computer on localhost. So whenever you can put whatever console log you want. So remember, this data is not being sent back to the browser. It's just being console logged to the terminal. So don't be confused about that. So if I make another request now, if I make a request for John, read, as we expect, it says get request for John. And if I make one for someone who doesn't exist, read, this returns an error, but it still makes a request, right? We made a request for Bob. It just happened that we tried to look Bob up in the database. He wasn't there, so we return an empty object. So this console.log is going to be super useful as your friend because it's otherwise really hard to debug these scripts if you're not printing anything out. Yes?
So the REQ and RES are reserved word for the .ps?
No, so that's a great question. So are they reserved words? No, they're just parameter names. So anything that you create in a function like this, anything you create in a function, the parameter names are free. You can name them whatever you want. You can name them X and Y if you want, right? They're not reserved words. It just happens that the convention is people call them REQ and RES. For basically, if you want to name them out, it's called request and response. Those are the two names. But what is, I don't want to say it's reserved, but what is the convention is that when the web app calls this function, the first parameter is the request object and the second parameter is the response object. That's why we call it REQ and RES. But yeah, so you can call it X and Y if you want, if you remember it. But yeah, so you'll often see in documentation, they call it request or response. But whatever you name it, whatever you name it here, you have to name it inside. You need to use this name consistently, right? RES, RES, RES. Right, but they're not reserved words. Oh, lots of questions. Here, we'll just go for yeah.
So does the function have to take the two arguments? Like, what if I want three arguments? Does that still be
That's a great question. Yeah. So does it have to take two arguments? So it actually has to take exactly two arguments because when the Express the Express web app framework eventually calls your function. So the kind of getting back to the question is who calls this function, right? Because can I just call it with one argument, three arguments? It's the web application framework underneath calls this function for you whenever you get a GET request, and it's expecting two arguments exactly. And the first argument needs a request, and the second one needs a response. So if you need more arguments, you need to do something a bit more special. I'm right off the bat, I'm not thinking of a reason why you would need more arguments there. Because you might have helper functions, you might be able to call another function and do something else. But yeah, it needs exactly two arguments, and the first one has to be the request, and the second one has to be a response. Yeah.
Yeah, so I don't understand when this function is called, what goes in the response argument, because we don't know what the response is yet.
That's a great question. So request makes sense, right? Because that's the request, and this is part of the URL of the request, and then you might have some other metadata about the request. So what is the response object? The response object, what you can think about is it's just, because everything in JavaScript is done in an object-oriented way, the response object is just something that represents what you're going to do with a response. It's not the actual response yet. So if you notice here, the only thing you do with a response object is you call res.send, right? So basically what res is, it's an object that has a send method. And the send method is what you call in your code to send the response to the browser. And this, you currently send the E, which is the element in the database, or you send an empty object. So it's just a way to send data. That's a great question, though. Yep, here, and then
Okay, so right now, when you click on the button in the client, it makes a GET request. And that GET request is first handled by your web API, which then calls this function. So
yeah.
So this function isn't called by the client. It's like handled.
That's right. In the server. Yeah. So actually let's go over the whole flow. This is great. So You're the one who made us draw this picture again. So let's see how many times we draw this picture again before the lecture ends. Right. So there's a button here, right? And what is it button? It's called a read profile or whatever. So when you click this button, there's some JavaScript code that is like button.click, right? And some code in button.click runs, right? Now still in the browser. And some code here has a .ajax. Not spelling this right. Star, whatever, $.ajax. That runs. And when that runs, it will just make a request here. And now the server picks up, the Node.js server, that picks up your call. It does some crazy magic. And then it calls this function right here, which is your code.
So the request is still GET request even though it's made via Ajax?
Yes. It's still a GET request. And it's because, so Ajax is not a special type of request, right? Ajax has to be a GET or a PUT or whatever. And it's a GET because you said GET right here. It's a GET because we said type GET. And then the other ones are POST and whatever other stuff. Yeah. But yeah, so this code is completely separate from the, whoa, what just happened? This code is completely separate from this code, right? Two different people can implement it and such. Yep, question up front.
Yes, so the response object, that's what you send to the Ajax function on success, right? That's the data parameter that we use on Ajax.
Yeah, so right, so let's go back to the other end. So we're on the server, and we say res.send e. And what e is, so what e is that e is actually a one of these things. So e is, for John, e is this whole blob of data. So when we say res.send e, what we really mean is it will send, this will send that whole thing as a JSON string back to the browser. Okay, and then now the browser code runs, which is, this is why these things are really hard to debug, by the way, because you have different things running in different places at different times. Where is it? Yeah, and then, as you mentioned, the success function runs with the E as data. Now,
That's the response object.
it's not the response object. It's the thing the response object. It's the res.send, right? The content of res.send. Yeah, it's not the response object. It's the thing that you're sending. And then this, again, this is not a reserved name. These parameters are never reserved names. They're just X, Y, Z. We just call it data just because it's easy to remember. You can call it X if you want and just make sure it's all X. And then it's up to the front end JavaScript code to parse this and to do the right thing with it. And again, you can console log here into your browser to debug as well. So always use console log if you're in doubt, because otherwise it's hard to see what's going on. Yeah.
Which side of the code should be written first?
Which side of code should be written first? Wow.
There's a lot of coordination.
Yes, that's a great question. Which side? So who is on the chicken and who's on the egg side, right? That's a great question. I don't think there's a great answer. I mean, I think usually what happens is, if you have a development team with multiple people, you're writing them in parallel. Right? You're probably designing that's why actually, your question brings up a great point, is that's why the API is so important, right? So the API, or the interface between the back end and the front end, is the layer. So if you actually design this well, so REST is one way to design it. That's why people like the REST design. If you design this well, then you can actually implement the front and the back end in parallel without actually knowing about each other, right? Because the front end just worries about getting all the stuff displayed and made right. The back end worries about getting the stuff in the database, putting it out, optimizing the server, or whatever. But as long as the front ends and the back end agree on an API that says, if I do a GET request, you better give me this data, then they can actually go in parallel. But if you implement just yourself, I say either one would be fine. Depends on what you like more. But that was a good question, though. Other questions? Okay, so we've gone through the whole path for the GET. And the other paths are pretty similar. They're just a little bit more convoluted because you have to put data and stuff. So, but basically, if you understand the structure of this sort of code, this is basically Express. So this is Node.js plus Express. This is a style of making a web app in Node.js and Express. As you have this app.get, you match a URL, you call this function, you grab the parameters out, and you do something, and you do a send to send back to the browser. So every other function looks kind of like this. So You can study the full code. So let's do update. Yeah, let's do update. Name to look up. Okay, so this is where we use the post body. Yeah, so this is what we want to do is we want to, if we want to update someone's information, so recall to do that, what we do is the update API is we want to do a put request to the person's name, and then in the body of the put request, we're going to put the information to update. So notice how the body doesn't have name in it, name equals Philip, because the name is implied by the URL, but it has all the fields we want to update. And the way to read this in English is put new data, blah, 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 into the Philip resource. So once we agreed on that, then the front end, just like last time, is very similar. So this is the, update button handler, this one. So this one has a put request now. The URL is, again, user / whatever the name we want is. And now we want to actually send data in the body of the request. We want to actually send data because we can't just name it all in the URL. The body is we want to update, we want to take the job and the pet, and we grab those from the text boxes. And we're going to send to this URL this blob of data, which has job and pet in it. So this gets sent, and the server needs to have a corresponding piece of code, which needs to handle it. So yeah, so this actually has a nice parallel here that this is the front end code and this is the back end code, and they kind of match up in a way. So again, the URL is now instead of app.get, we have app.put, which is conveniently enough, which is what do you do when you have a put request? And then we're going to match this user /star, same function, whatever thing. We're going to do name to look up, which is the exact same name as before. And now we're going to go loop through the database. And this is what we're going to really focus on, which is if a row matches the name we want, then this is where we're going to use that your question of the body parser. So if you import the body parser and you set it up right, then the request object actually has a .body parameter, .body field now. You need to do the body parser setup because otherwise it doesn't have a .body. So if you set it up all right, there's a post body, and then you can you loop over all the things in the post body. This is just a lot of JavaScript. You can go over it offline. But you basically just override the value. So what this kind of loop does is it goes over, looks for the row that matches, and then it looks for all the things in your post body, and then it just overrides the values. So take some time to look at this by yourself. And conceptually what it does is, let's say I want to change my job to cat herder or whatever. Let's say I want to change John's job to unemployed, right? So if I want to change John to unemployed, I look here. No, it's not John. No, it's not John. Yes, this is John. So what I do is I look in my data that I sent, and I look that job is unemployed now. So I am just changing this to unemployed, the string unemployed, and then I'm done. So conceptually, it's pretty straightforward, but you have to write a little bit of JavaScript code to loop through the body and where's the put? To loop through the body and everything. So this code right here basically does the actual put stuff. So if you look at this code and you think, this is a little confusing and such, it'd be nice to have a better way to write this. This is exactly what SQL is for, right? So when you learned in one of the earlier lessons, this is exactly why people have databases and invented SQL. So you don't have to write this looping thing to look up stuff and whatever. You can write an SQL command to do this if we actually use an SQL database. Just happened I didn't want to set up a database, and I want to show you that you don't actually need a database to do this. But this is exactly why people create databases. One of the reasons, right, is that you don't want to write all this manual code for looking up names and updating values. You can just write a nice SQL statement for doing that. And it's very possible to do that in Node. You just have to import a SQL library and make a string and call it, just like in Python. And that's pretty mechanical. And the send, so the question is, after I put the data in, what I send back to the client? Right, so we're just going to send something really simple. We're just going to send a string that just says OK. And if there's an error, like if you can't find it, we send an error. So we just send a string back to the user. And the user, the browser takes that and just, it's getting messy. The browser takes that and says, you received some data. And this is exactly what the browser does. It says, if the data is just OK, then we say, OK, update it user. If it's not OK, error could not update user. So it's up to the front end to handle the response. It's either OK or error and print out the thing. So to demonstrate that in action, demonstrate an action. If I try to look up, first make sure I'm still here. Yep. If I update my job to cat wrangler, still cat. If I update, it says successfully updated user. Great. If I try to update, say Bob, to cat wrangler, it would say error cannot update user. And it's an error because we couldn't find Bob in the database in the first place, so we return the error string. So yeah, so there is a lot of coordination between the front end and the back end, because your front end code is completely independent from your back end code. So that there is sort of this, you're kind of writing similar code in both pieces there, and it's because your front end runs in your web browser and your back end runs in your web server, and they could, for all intents and purposes, be written in different languages. It just happens that they're both written in JavaScript now. So notice how every function in the front end has some corresponding thing in the back end. So this is getting back to your question in the middle here. If this annoys you, if you find this irksome and you find there must be a better way to do this, right? Why is the front end code and the back end code separate? Then if you're really, really brave for your final project, you could try out this web application development framework called Meteor.js. Has anyone heard of Meteor or Meteor.js? One brave person, 2 brave people. So this is an application framework called Meteor.js, which you're welcome to try for your final project. And Meteor.js was developed to exactly solve this problem I pointed out here, is that if you stare at the code, this code is JavaScript that runs in your browser that has all this stuff, and then it calls this JavaScript code on your server that has all this stuff, and they're running completely separately, but they're conceptually 2 halves of the same thing, right? You're doing some requests, you're doing stuff, looking at the database and going back. What Meteor allows you to do is it allows you to write one piece of code that does both of these things together. And the Meteor compiler magically factors out your one piece of code into client and server code separately. So to answer your question, if you had Meteor and you worked right, you could just write one piece of code, and that actually magically goes in the client and the server. Quite a few people have used Meteor with some success and have really enjoyed it. The main downside, I would say, to using Meteor is that it operates at an even higher level of abstraction than you're used to with, already with a web app framework, you're already, I'm already having to say more like, oh, don't worry about how this works. The framework takes care of this, the framework takes care of that. When you're working in Meteor, the framework takes care of like pretty much everything, which is good if you follow their examples, but if you want to do something different than their examples, it's impossible because it's meant to work in a certain way. So people have used it with great success for some projects, but just be warned that the more the framework does for you, the less you're going to know about what's going on, and the harder it will be for you to debug. But I encourage you to try it if you are brave enough to try this. But it is, it's well supported. They have tens of millions of dollars behind this. It's an open source project. There's a company behind this, and also, but it is a pretty solid project. It's meant to solve this problem of we have 2 halves of the same thing. Can't we just squish it all into one since they're all in JavaScript? And Meteor actually uses the exact same technologies that we've been teaching. So it uses Node, it uses Ajax, it uses WebSockets. So it actually uses exactly what we've been teaching, but it just gives you, again, a more convenient way to do that. But this is kind of the level we're sticking with for the class for the time being. All the other commands are exactly the same. So you can all go over this offline. This is delete right here. Same pattern, just app.delete. And then we specify URL, right? Delete the user, look up the user, and basically we go through the database and we just do the splice function takes an element out of the list in JavaScript. So it's a delete, and then the put, what is it? The add new user, create new user, is this code right here, which is, it looks up the person's name from the post and everything, and it creates a new user. So that fully implements the server side of the equation. So when you're making an app in Node.js and Express, most of your code will be in these kind of URL handlers, right? So the one thing I want to mention here is now that we have this, what this web application framework gives you is that it gives you the ability to handle arbitrary URLs, right? So because we have this wildcard star matching, we can now handle things like, actually, let's just do this directly. I don't know if I didn't do this directly. So a GET request is simply, so let's go here, and let's just do a GET request for users Philip. Because this is a GET request, right? Because the web browser, when we visit a web page, does a GET request. I am requesting user/Philip. So what should this do? Assuming it works. Where should I see printed out? Yep.
JSON file.
Yeah, it should print out JSON, a blob of JSON. Exactly what it does. Yep. So this actually, you can just do it in your browser because a browser does a GET request. So it actually makes it nice to debug. So if I visit this URL, which is exactly what my Ajax is doing, I'm just doing it manually, it gives you a JSON name, Philip, Pat. Oh, notice I actually changed my job. So it's actually Cat Wrangler now. So if I say John, it'll give me the JSON data for John. If I do Jane, and if I do someone who's not in the database, it'll give me the empty JSON object. So the cool thing here now is that with the web application framework, it will handle arbitrary URLs, right? Because when we had AMPs, like the old AMP setup, you actually have to have a file for every URL you visit, right? Otherwise, it'll say file not found. And it's because in the AMPs framework, in Apache, every URL needs to be a file. But with this web application framework with Node.js, there's no reason why these need to be files. So that's basically the secret to how you can implement these nice clean URLs that aren't actually files, right? Because if each one was a file, we don't have a file named John and a file named Philip and a file named James. These are all just strings that the application framework takes and interprets and runs the right function. So whatever we're visiting, Philip, John, whatever URL we're visiting, the framework, the Express framework with Node.js will always call this function with the rec param 0 set to the thing we need. So this gives you a way, the web application framework gives you a way to handle an infinite number of URLs potentially, right? And it's just because a URL is just a string, it just does stuff with the string and parses it. Yep.
Now, for like real web applications that implement a REST API,
Mhm.
do they have to come up with some way that normal people can't go to these URLs and see people's data?
It's a great question. Yeah. So, if you're on Facebook or whatever, which I think has a REST API, can't you just go to Facebook, whatever, /users and see everyone's data, right? So you can do that, or you can, go to curl. Whoa, a lot of requests here. I'm gonna stop the server. So you can just do a curl on the command line for this, and assuming, stop the server. Okay, that didn't work. That's great. A smooth demo didn't work. If you do a curl, it's the same thing, right? So this is look, Powered by Express. Oh, great. So it actually, wow, it like egocentrically put itself in the header. Okay. Wow, that's great. So it's Powered by Express. Awesome. Good advertisement. So, yeah, put itself in the header. Yeah, so if you request Philip, there's a header, and then there's just the JSON. And it says JSON, right? The type is JSON. So, if you don't do any protections, anyone can use curl to get your data, or someone can go on your web browser and get your data, right? So the way that this is handled is by authentication and the kind of cookies and authentication and security. So on Facebook or on Twitter, for example, let's say Facebook, there is a REST API, I'm sure, but you have to first get some token and some secret string or whatever, and then with the secret string in your browser somewhere, then you visit the URL, you see it. And if you don't have the secret string, you visit the URL, it'll probably say blocked or something. But for your project, as I noticed in notes, you don't have to worry about that, the security part. You do have to worry about getting a login so they can actually log in, but don't worry about making it like password secure or whatever. As long just store your password in the database. Again, don't do this in real life, but for the project, don't worry about the security. As long as they have a username, password, they can log in, just match the string and stuff. Cool. Other questions about the frameworks? Yes?
For now, I'm sending JSON objects, but is it possible to set up the strings and pictures in the front end
Yeah.
using the server.js?
Yeah, so you mean to actually return a whole web page with pictures and stuff. Yeah, that's great. So what we've done, as you pointed out, is so far we're really only using the back end, all this dynamic code, to do a Web 2.0 thing, right? We're really just doing, this is Node, we're really just sending little blobs of JSON data back, right? We're just sending little tiny bits of JSON data and having the web page, the JavaScript in the web page parse the data and stuff. But remember, if we go all the way back to Web 1.0, what it did is instead of sending little blobs of JSON, it sent entire HTML web pages back, right, with pictures and with everything. And you can certainly do that. So because your server is just whatever, you can just say res.send, a gigantic string that contains all your HTML, right? So you can send anything back, and the browser needs to know that it's HTML and stuff. So you can do that. So then the question is that you brought up is, how do you make this giant string, right? So you can go really old school, like the Python code, and just make a giant string out of all the things you add the strings together. But another nice thing about web frameworks that we didn't go to in this lecture yet is that a lot of web frameworks use what's called a templating engine on the server. And what that lets you do is that lets you write HTML in a file and then put little holes in here for variables. It lets you put little holes where variables go in, and then you run your template engine on your HTML file, and you fill in those holes on the server. So this lets you basically generate the HTML web pages on the server dynamically. Just for this example, I think it's easier to have just a static web page and then just send little pieces of JSON data back, because it's more Web 2.0 like. But you can definitely create the whole web page on the server and send it back. Yeah, that's definitely possible to do. And that goes into what web frameworks give you, right? So I'm telling you more and more features they give you. They give you a template engine. They also give you a, what was I saying last time? Oh, they give you database access libraries. They give you authentication. So this is just more and more piles of stuff that the application form will give you, which I haven't shown all of it. So if you look at, again, Wikipedia Web Application Frameworks, now you're getting kind of a better sense of what these frameworks are. They're just nothing more than collections of code that help you. So where is the comparison? It is down here. Yeah, so if you look at, so they have Ajax. MVC is this model view controller thing. The ORM is a database thing, more database, security, caching, template framework. So a lot of frameworks come with some template framework that you can generate these HTML pages. But yeah, again, all this is just look in the documentation for what you need. Alrighty, so let's go back to here. REST API, course recap. Okay, so this is basically an overview of the entire stack. So this, again, in our simple example, is just one server.js file you implement, and you get all the dependencies right and everything, and in the real thing, you're going to have a database. And this is an entire app, right? I mean, if you deploy this, it will run, and you can actually have a bunch of people connect to it, and it'll just work. And you can host this somewhere online, but for your project, you can just host it on your own computer. Okay, questions before we go into just a general recap of everything? Yep.
How do you go about hosting online?
Sorry?
How would you go about hosting it online?
How do we go about hosting online? Good. So I purposely avoided this question for the class project by saying you don't need to host online, because it's a whole other big morass. The way to do it typically is you get either a paid service or some free service. There's a bunch that people recommend. Basically, the easiest way to do is you look up some service. Either there's a free trial or you pay $5 a month, $10 a month, and it gives you some access to some server, and you upload your files on there. Or sometimes just from GitHub you can upload your files. You can also run your own server, but then that also just gives more complications. Yep.
If you're a CS major here, you have WebSpace.
All right, there we go. Yeah, and I don't know what the extent of running scripts on the web space is. So you have to check, it might let you run CGI scripts, it might let you run. So that's the thing, right? So universities usually let you have web space, but a lot of spaces only let you just serve like a static file, like an HTML file or thing. They might let you run scripts, but again, you have to check with the admins. Yep.
To add on to that, if you do the GitHub student developer pack, I think they give you, last time I checked, $100 for DigitalOcean.
Oh, cool. All right.
Service. So
that's good.
But also, would you recommend trying to use web framework for our projects, or do you think it would be better to forego that? That's a great question. I think, we should ask about project questions too, since we have about 10 or 15 minutes left. I feel like, I could go either way. It depends on what kind of languages or things you're comfortable writing in. So one thing that we didn't cover in this class at all was PHP. So PHP, if you actually have done it before or studied it, is actually a pretty easy way to get web apps up and running, because it's a pretty lightweight language. I would say, I don't have a great recommendation either way. There are codec. The nice thing about me putting up the code examples on it, there are examples of doing it in the old AMPS way with the Python, or there's the Node.js way, or if you know PHP already, you can use that. I think, yeah, it's hard to say. It's really what your team members know, right? I mean, if you all are super familiar with PHP, you should use that. If you're all familiar with whatever, you should use that. So I mean, this is a problem that comes up in the real world too. Of what language should we use? It's whatever you feel like, using. And I think the project can be completed well with any, with framework or no framework. Questions? Project stuff? But yeah, that definitely came up a lot last year. And this is a chance to experiment too, right? I mean, if you play with the framework for half a week or a week and you say like, oh, this is terrible, I don't want to use this, then you don't have to feel obliged to use it at all. Right? It's really just there to help you if you need. Oh, and the other piece of advice for the project that I was telling online was if your project needs to connect with like data elsewhere, like the web services and stuff, that's fine. But one way to really demo it is just to like grab some fake data or just grab some data and just like put it on your computer, because like nothing is worse than you're trying to demo and then like it doesn't work because like the connection is broken or like, their server's down or some little API thing has changed. So for purposes of this class, as long as you have enough kind of data to make it look realistic, it's fine. Like, some people I know want to do like flight data or other data, just grab a bunch and just put it on, on your server and stuff. And it's a much easier way to do it than having to, do it live. But I mean, obviously if it works live, it's more impressive, but just for testing also, just, basically try to test everything locally. Okay, so the course recap really is we've actually covered a lot of ground in 12 lectures. I mean, the past 8 weeks or so, we covered a ton of ground from, let's see, we basically covered the whole gamut of making a web application from start to end. We started with this web pages as documents thing, so this is from first part of the class. So with HTML, CSS, we did these web servers, we did this old Web 1.0 style, we had some database stuff, we had logins. Then we did the DOM with JavaScript, Ajax, some local storage, so this is a small lecture on just being able to store stuff on the browser. And then we have this modern stuff with REST APIs and WebSockets. So the whole picture really is, let's see, we'll just draw the whole picture out. Promise, this is the last time you're gonna see this picture, except maybe on the exam. So the whole picture is you have a computer here, or you have a bunch of people's computers, and these are clients or browsers, and then you have one server hosting your app, and this lives somewhere. You either maintain your own server in your room, or you most likely rent server space somewhere, and this has a web browser inside, and the web browser, you load up HTML files, CSS files, and then JavaScript for your front-end code. And the server runs some server software on it, which is either Apache, which we've seen in the first class, or Node.js. And then this has some, server code that you write. So either these are CGI scripts or your .js files for your Node.js. And then what happens is that all these clients make requests, and then you respond. And this is basically, in the Web 1.0, you respond with an HTML file. In Web 2.0, you respond with a JSON, data, and then in the newest case, you can, instead of using this request response model, you can also use these things called WebSockets, which directly connect to your server. This WebSocket interface, which directly connect to your server and have this two-way communication. So from the WebSocket lecture, they actually use Node.js for the WebSocket connection. So Node.js also does WebSockets as well as regular HTTP. And then you have your front-end code do all the rendering. You have all your server code. Oh, there's also somewhere, if we have space to draw back here, you have a DB or a database somewhere that your app queries and gets back to you. So this is basically what modern web apps just look like this. Right? You have a bunch of this is called the front end. Traditionally, this is traditionally called the back end. And they have different people working on these different parts. And they interface mostly through this kind of request response model. Or a newer one is this WebSocket model where both sides can go and send data back and forth arbitrarily. There's some server software, Apache, Node, whatever you use. There's some database here. And that's that's pretty much it for all the interfaces. So, you know, to kind of end the lectures on a note of where to go from here, right? So everything you learn in this class really is the fundamentals of how you build these web apps. But if you actually are going to your internships and jobs, you'll find that there's a lot of layers on top of this of complexity, right? Because for this, you know, if you want to scale this up to you know, real world usage, there's probably a lot of stuff you have to put on top of to make it work better. But fundamentally, if you peel back all the layers, it basically goes back to this, right? It goes back to front end, HTML, CSS, JavaScript, some request response thingy, some WebSocket thingies, some servers, some databases, and such. So going back to the syllabus here of what this course did not cover and what you want to maybe learn in the future, because there's a ton to learn beyond this course, is this, right? So this is what does this course not cover? We will not be tested on this. So this is what we did not cover. Really in this course, right? So these are all entire professions to themselves. I mean, you can get high-paying jobs in all of these individually. So graphics, right, and typographical design. So this, you know, front-end design is clearly super important because that's exactly what users see. This is also important because of now people are on phones and tablets and smartwatches and stuff. So really doing good front-end design. Second one is related to usability and accessibility testing, right? So not just how it looks, but how it feels, you know, testing with users. This is much more what the HCI class covers, 212. And also accessibility for people with, you know, disabilities or kind of, you know, visual or auditory impairments. So this is a whole field to itself. This is your question earlier about deployment you know, there are people who get paid a lot of money just to do this, of how do we deploy your web apps online? How do we configure your cloud? How do we configure your apps and make sure it's running? And if something goes down, to, you know, call the right person to fix it. How do we debug it? This is a giant topic. Security and privacy are gigantic topics, right? Because, you know, you want your stuff to be secure. You want to keep user data private. Performance is a gigantic topic. We need to actually make these things run fast when we have millions of users or billions of users, as Facebook does, right? So clearly that picture, if we just have one server, is not going to fly, right? They have thousands or tens of thousands of servers and coordinating. Data storage, related to the performance thing. When you're storing terabytes, you know, of data and trying to get at them fast, you have, you know, a billion users like Facebook does. You're probably not just storing data in one table. Also testing and quality assurance. So this is, again, these are all professions, right? How do we make sure the web apps work well? Because as we even see in the simple example, it's hard to test these, right? Because you have a browser side, they have to click, and then they have to go through some internet thing, and that might be unreliable, and the server has to run separately and go back to client. And then the final thing, here, which is often overlooked in projects, but is super important, is product management. And product management is to actually determine what you actually want to build, what product you actually want to build and what features you want to add, rather than the how of how to do it and the mechanics of how to do it. Because you can be spending, you know, millions of dollars building a product that no one actually wants to use, and you have all this effort invested, you're writing millions of lines of code, and in the end you release it and like nobody uses it. And everybody will have wasted their time and been sad. So all these topics are super cool to study. You know, most likely you're going to learn a lot of these on the job, right? Because there aren't really, you know, there's some classes in some of this, but a lot of this, the reason why there aren't like, you know, exact classes on this is because the technologies are so specific, right? You know, in order to learn how to do, you know, if you go and work for Facebook, they have their own data storage and processing backend, and you learn their own system. If you're at Google, they have their own system. And there are some principles that kind of underlie it, but really it's a lot of specifics for the entire each company's needs. But no matter what, everybody's apps look kind of like this if you squint hard enough. So we have a few minutes left. I'm happy to take questions about project or anything else, but I'll be around for 10 or 15 minutes. And my office hours are tomorrow. And come back here for exams, same drill, pen and pencil and paper. And I'll see you here Thursday for the exam.